In this video, we are going to discuss how to solve absolute value functions graphically, meaning when they're already graphed, or when you have graphed them already, trying to figure out where the solutions are if we are looking for an absolute value function to equal -1 or equal 2 or equal 6. So I've already plotted the first graph for you. So they gave us a graph. I used the vertex and the slope of the branches to graph the absolute value function. Then they're asking me, where does the absolute value function equal -1? G of x equals -1 is just a horizontal line. So we are going to graph a horizontal line at -1. That would go from -1 here straight across where all the y values are -1. The goal here is to see, where does the absolute value function intersect the line that we graphed. So the absolute value function and the line that we graphed cross at these two values. Similar to the way that we solve systems graphically, that's what we're doing here. We're technically solving a system of nonlinear equations. Okay, but we are seeing that these graphs intersect at the point -2 and an x value of -6. So your answers are -2 and -6. Let's try another example. I've already graphed using your vertex 5, -3, and the slope branches, which were 2 and -2. From here, I'm being asked, where is this absolute value function equal to 5? So I'm going to plot the line y equals 5. So I count up on the y-axis, 1, 2, 3, 4, 5. And I draw a horizontal line at y equals 5. Notice that if you don't draw enough points on your absolute value function, you might not see it. So you really want to be sure that you continue your graph so that you can perfectly see the intersection point. You can notice I had to fix mine here. Okay, so from here we are looking for this graph of the absolute value function to intersect the horizontal line. So the values that this happens at are x equals 1 and 1, 2, 3, 4, 5, 6, 7, 8, 9. X equals 9. Those are the solutions to my absolute value equation. Where does this absolute value equation equal 5? Sometimes they'll write it a little bit differently, where they're putting the absolute value function on one side and just a number on the other. So they're asking you, where is this absolute value graph equal to -2? So I would start by saying, okay, I'm going to need my vertex, which is at -1, 4. And I'm going to need my slope of the branches, which is -2 and +2. So I'm going to go to my vertex, -1, 4, plot the point. Because the a value was negative, I know that this absolute value function should face down. So from here I'm going to count down 2, right 1. Okay, but keep in mind, that's only half of my graph. So I'm also going to go down 2 and left 1. And plot enough points so that when we go to graph our line, we can clearly see the intersection point. So we want a horizontal line at -2. So we want to graph y equals -2. -2 would be down here and come straight across. So we'll see there's two answers here. We have an x value of 2 and an x value of -4. Those are the solutions. Okay, now, will an absolute value function always have two solutions when you are solving? Absolutely not. Had I asked you where this absolute value function was equal to 4, okay? If you were to try to draw a horizontal line at 4, the horizontal line would only touch the absolute value function in one spot. So this answer would just be x equals -1. Okay, that's the x value of where they intersect. Had I asked you, where does the absolute value function equal 9, you would go to plot your line at 9 and notice that this horizontal line never touches that absolute value function, in which case this would have no solution. So a line and an absolute value graph can intersect one time, giving you one solution, two times, giving you two solutions, and not at all, giving you no solution. We'll see some examples of this algebraically in the next video.